So, in today's class, we're going to be using radian measurements, okay? Now, the radian measurement is basically, one radian is the measure of the angle at the center of a circle subtended by an equal arc in length to the radius of the circle. So an example would be this. I could have any circle I want, so obviously a triangle. I could have any circle I want, okay? And what I have here is, if I have this is a radius of 2. If my arc length is also 2, what I mean by arc length is from here to here, okay, going this way. If my arc length is also 2, this means by definition the angle must be 1 radian. If I call this 100, call that 100, that also has to be 1 radian. Okay, so that's what we know about radian. That's the definition of radian. Okay, now moving on. Alright, relationship between radian and degrees. Okay, so if I take a circle, alright, any circle whatsoever, and we know that its radius is r. Okay, what we know about the lap of the full circle, or the circumference of the full circle, is 2 pi r. Now 2 pi r is the radius of the full circle. Now imagine if I showed you this question, okay? Now just after showing you one a second ago, I'm going to come back to that now. I showed you one a second ago that was like this, okay? If I said this is a length of 5, and I said that's a length of 5, how many radians do I have in here? 1. Okay, if I said this was 15, how many radians is my angle now? 3 radians, okay? Now, if I said, for instance, if I said this is r, and I said this arc length here is, we'll go for, I don't know, 3r. What would you tell me about the amount of radians in there then? 3r. 3r, okay? Now, the whole circle itself, the whole circle is 2 pi r. So how many radians in this full circle? 2 pi r divided by r, which means just 2 pi radians in a full circle. How many degrees in a full circle? 360. So 360 equals 2 pi, divide by 2, 180 equals pi radians. It's basically the same thing as me saying that 30 centimeters equals 1 foot. It's basically just an equivalent measurement, okay? Now, so that's what it means. 180 degrees equals pi radians. Now, what happens here is, we now know that pi equals 180. When you divide pi by 6, you get 30, don't? So when you divide 180 by 6, you get 30, right? And that's why it's pi over 6. 45 goes into 180 how many times? 4. That's why it's a quarter. 60 into 180? 3. That's why it's a third. Everybody get the gist of it now? What about 270? What's 270 divided by 180? 3 over 2. And that's why it's 3 over 2 pi. Okay, let's move on to the actual questions now. Okay, I'll use that one in a moment, okay? I'm just going to move on to some of the basic questions first, okay? Alright, express the following numbers in radians, okay? Now, the only thing I need to have learned off by heart to do number 5, okay, is this. 3 pi over 5 in terms of degrees. Also I need to know is pi equals 180. Pi radians equals 180 degrees. So all I have to do is get 3 over 5 and multiply by 180. What's 3 over 5 multiplied by 180, anybody? Sorry? 108. 108. So that means it's 108 degrees. What about pi over 6? Pi over 6 is basically going to be a 6 multiplied by 180, which gets me 30 degrees. That's how you do those questions. Very easy. Okay. Next type of question. In the questions, 11 to 25, express each of these angles, leaving your answers in pi, in terms of pi. Okay. Now here's what we do. Anytime you get a question that's in terms of degrees, write down your number of degrees and divide it by 180, and that will automatically turn it into terms of pi. So what's 130 divided by 180?
6.
A sixth. So it's a sixth of pi. Let's look at this one, 135. What's 135 divided by 180?
3/4 pi.
Was it?
3/4 pi.
3/4 pi. And finally, 450 divided by 180?
5/2 pi.
9/2 pi.
5/2.
Huh? 5/2, sorry, excuse me. So look, guys, that's it. That's how you do all the questions pretty much all the way up to 20. Okay, moving on. Okay, gonna stop here now. First of all, find the length of the minor arc, PQ. Now what minor arc means is it's the small one. You could also call it the arc PQ could also be represented by the red line as well. And that would be obviously called the major arc by just logic. Okay? So what we're going to do here is we're going to look up a formula. These formulas are in your tables. L equals R theta. Theta has to be in radians. If it gives you the angle in degrees, what do you need to do? Convert it into radians, then use it in your formula. So what we're going to do here is we're going to say, okay, L therefore is equal to R, which is 4 centimeters, multiplied by 1.2 radians. And the answer for the length of the arc, this arc here, is going to be 4.8 centimeters. That's how easy that is. Next thing, the area of a sector. Okay, the area of the sector is going to be A equals a half R squared theta. And what we're going to do here is we're going to say it's a half 4 squared times 1.2. Will anybody get that for me in the calculator for me, please?
4 times 1.2.
It's basically 8 times 1.2, 9.6? Is it? Anybody in the calculator with this?
Yeah.
I'll put it up. 9.6. Once again, it's an area, so it's centimeters squared. Okay, guys, moving on. Now, a slice of cheese has a 2 centimeter thick. A slice of cheese 2 centimeters thick, which is the height, has a cross section that is a sector of a circle. Basically means this part here is the sector of a circle. If the radius length is 5 and the arc length is 6, find the volume of the cheese. Okay, so what I will do first is I'll draw a 2D model of this. The first thing about the two-dimensional model is that I'm just going to write down the arc, okay? The arc length is 6 centimeters. The radius is 5. I'm going to find out what theta is, starting off. Okay? The angle is L equals R theta. By this logic, theta on its own equals L over R. This means that it's 6 over 5 radians. Okay? I got the angle. Now, please remember, volume of an object equals area multiplied by height. It equals the area of the face multiplied by the height. An analogy would be, imagine stacking tons of sheet of papers on top of each other. You end up multiplying the area by how much it goes up, because it's the same area each time. So volume is how much space does it occupy. So what we're going to do here is we're going to find the area of the sector. You look up the area of the sector formula, a half R squared theta. Can somebody tell me what a half 5 squared 1.2 is? Anybody?
15.
Sorry?
15.
15?
Yeah.
Okay, so it's 15. The area of the face is 15. What's the height of the object again? 2. 15 by 2? 30 centimeters cubed. That's your volume of your cheese.
How'd you work out it's 1.2 radians?
I did it here. L equals R theta. Theta equals L over R. And then I put L is 6 because its outside section is 6. 6 divided by 5 is 1.2 radians. Okay? I'm pretty certain 6 divided by 5 is 1.2. Yeah. Okay, guys. Next one. A sector OAB has an arc length of 12 and an area of 48 centimeters squared. Write down 2 equations in R and theta as shown. Okay, guys. To figure out how to do this, here's what you do. Sector has an arc length. Write down the formula for the arc length, like so. That's one equation, right there, on the board. Okay? The next equation is, the area is 48 centimeters cubed. Rory. The area is 48 centimeters cubed, which is a half r squared theta, which ends up to be a half r squared theta equals 48. Now, we have a play here, okay? I've got to show you what it is. We've written down both equations, as shown. Now, what does r squared theta actually mean? It means a half r theta equals 48. Why did I arrange it like that? Because the r theta on top is equal to, so in effect this here can be replaced with 12. So what is a half 12 multiplied by r? 6r. 6r equals 48. r therefore equals 8. And then finally, what do I have to find out then? I have to find out the value of theta. So L equals r theta. So 8 theta equals 12. Theta equals 12 over
8.
Theta equals, you won't get full marks for that, that'll be 3 over 2. Okay guys. Last one. A piece of wire 40 centimeters in length is bent in the shape of a sector of an area. The length of the radius r and the sector angle is theta radians. So that theta equals 40 minus 2r all over r. Okay, you got your sector, like as shown. Now, you know that when this wire is broken and unravelled into a straight line or whatnot, it has to be 40 centimeters in length. Here's the radius, here's the other radius. How much do we have left for this section here? 40 minus the distance of the two radiuses, which is 40 minus 2r. Theta, L equals r theta. Theta on its own equals L over r. L is 40 minus 2r, and r is still r. Done. The area of the sector is 100. Figure out what is the value of r and the value of theta. So you're going to use your area formula, which is a half r squared theta, and what you're going to get is a half r squared 40 minus 2r over r equals 100. You cancel it out, that r with that r. Then you're going to multiply in by a half r, so you get half 40, you get 20, multiply by r, you get r. Half of 2r is 1r, 1r multiplied by r gives you minus r squared equals 100. You understand that you're going to do a quadratic equation. I'm going to stop it there. Okay guys.